All right, so we're back here to finish this problem up. And again, what we determined was now that for this third equation, I need to get 1 mole of tungsten carbide on the right. I've got 2 moles on the left. Hopefully you took the time to go ahead and see if you came up with the right answer on your own. If you haven't, just pause the video, go ahead. We know we need to flip this equation and divide by 2. So pause the video if you haven't done so and go ahead and do that. We're going to go ahead and do that, flip the equation. All that means is everything that is on the right side now is going to go to the left, everything on the left is going to go to the right, and at the same time we need to divide this stuff by 2. So let's go ahead and do that. WO3, again 2 moles down to 1. CO2, again 2 moles down to 1. And now let's go ahead and take these things on the left side and make them on the right. There's our 1 mole of tungsten carbide and 5/2 mole of oxygen. What do we get for a delta H in this? All right, we know we divided it by 2, so we're going to take our delta H, we're going to divide by 2, and because this was a flipped equation, we also need to change the sign. We know that as the equation is written, it's an exothermic reaction, negative in there, it's an exothermic reaction. So when we flip it, we know it's going to be an endothermic. That's why we need to change the sign. So delta H in that case is positive 1195.8 kilojoules. Once we're at this step in the problem, everything should manage to add together to give us the equation we're looking for. This is what we should be left with. So how do you do that? Well, let's take our equations here. And if you see anything on opposite sides of the equation, you know they're going to cancel each other out. For instance, just give you an example here. Right here I see a mole of carbon dioxide on the left. Here's a mole of carbon dioxide on the right. If they're on opposite sides of the equation, they can cancel each other out. I notice also the WO3 does the exact same thing. They have 1 mole on the left and the right, so they cancel out. And I think we've got one other thing we need to cancel here, and that's some of these oxygens. Looks like I've got 3/2 oxygen here on the left. Here's 5/2 on the right. So what's going to happen? Well, I know they don't completely cancel out, but I do know that 3/2 oxygen is going to cancel out 3/2 here. We're going to be left with 2/2. That doesn't quite do what we need. Ah, there it is right here. There's that other oxygen that's going to cancel out. So believe it or not, those oxygens do go away. 3/2 plus 2/2 is 5/2, cancels it out. What do we have left here? Well, it looks like tungsten, carbon, tungsten carbide. What did we need? Hey, check it out. Tungsten, carbon, tungsten carbide. We've got the things we need. We've got them in the quantities we need them, and we've got them on the sides of the equation we need it. So we are actually left with exactly what we were trying to find. And again, that's the whole point of Hess's law. If you don't know an equation, you can take other equations, manipulate them to get exactly what you need. And of course, the other point of Hess's law is the fact that you can also do the exact same thing with the delta H's. Now that we have our delta H's for these equations, all I should have to do is add them together, and that should give me the delta H for my unknown equation. And in this case, it comes out to negative 38 kilojoules. Again, all I did was add these 3 delta H's together right here. So that's how you do a Hess's law problem. They're a little challenging to get started with. However, once you do a couple of them, they're actually not that bad, and we will be working on a couple of them. So go ahead, go back and take a look at this one. Make sure you have it copied down. Make sure you understand how we get started. And like I said, we will do a couple other problems.